Hello, geometry students. Today we're going to be taking a little bit deeper look at the equations, looking at the ones that involve more steps. Previously we looked at simple solving equations, where you only had one or two steps that were needed per each equation. Well, that works fine for Algebra 1. It even works fine mostly for geometry, but as you're going to see moving into Algebra 2, you're going to need to be able to solve equations where several steps are involved. That means you're going to have to be a little bit more deliberate with writing out your work. Some of you have a habit of skipping steps, trying to do too much stuff in your head, and that will absolutely cause you nightmares as far as trying to solve equations in Algebra 2. Okay, so let's take a look. 3, 4, and 5-step equations. If my screen will turn the page here. Our objective is to master solving of equations when 3 or more of the 5 steps are needed. I think what you're going to find as you move into Algebra 2 is the vast majority of equations that you end up needing to isolate a variable in, you're going to need probably 3 steps of the 5 steps and sometimes 4 steps of the 5 steps. Very rarely does an equation actually bring all 5 steps into play, but what you will run into is perhaps a problem will need one of the steps more than once. So you may actually end up doing 5 steps, maybe even 6 different procedures trying to get through the 5 steps. It just depends on how the equations are set up. Okay, so just like yesterday, we're going to take a look at some equations here in a moment. I'm going to spare you the extra time of going in and checking the problem. I think you should know by now I've stressed the importance of checking your answers by plugging back into the equation, but I'm not going to spend your time doing that in the notes tonight. Okay, so once again, our 5 steps for solving equations are to deal with parentheses and multiplication first, combining like terms on the same side of the equal sign, then picking a direction to send our variable in the equation, then moving everything else away from the variable, and then accomplishing our 1 and 1 coefficient and exponent for our variable. And of course, my cutesy little term or saying for remembering this is parents' complaints vary for everyone. Okay, so let's take a look at some problems. Okay, now as you can imagine, in order to need more of the steps, the problems are going to appear more complicated. Okay, but keep it in mind, it's just one step at a time. Just like with geometry, the key to not allowing geometry to freak you out is to focus only on the part of the picture that's important at that time. The same thing is true with solving equations. Don't let the big picture scare you. Focus on the little pictures. Okay, so in this equation, 1 equals 2/3 of w divided by 6 minus 2. It looks nasty, but walk through your steps one at a time. Okay, so step 1, parents, that's for parentheses. We look in the problem and we can see that right off the bat we have a parenthesis problem. Okay, so we need to do a little bit of multiplication in order to rid ourselves of those parentheses. Okay, so we're ignoring the 1 equals, we're ignoring the minus 2, and we're just focused on combining those two fractions by multiplication. Now, of course, remember, it's the distributive property, even when it's just one term times another term. And when fractions are involved, we need to multiply the numerators together, and we need to multiply the denominators together. So obviously in the numerator there, we have 2 times w. Well, that's just 2w. And in the denominator, 3 times 6 is 18. So let's combine those. Okay, so that takes care of the parentheses and the multiplication. That part is done. So you move on to step 2, and it goes, okay, combine like terms. Okay, well, we do have a binomial on the right side. However, the left term is a term about w, and the right term is a constant. W's and constants will not add together, so we cannot combine like terms. Now we're looking for the variables all being on one side of the equal sign, and they are already only on the right side, so we did not need that step. Now if all the variables are on the right side, Okay, step 4 is to move everything else the other direction. So that -2 does not need to be hanging on to our variable. Okay, so we need to move -2 to the other side. How do you move a -2? You do the opposite of subtraction, which is addition. If you want to get rid of a -2, you're going to have to add 2. But as always, anything that you introduce into the problem, you must do to both sides of the equal sign to keep that equal sign balanced. Now, obviously, on the left side, we have 1, and now we have an additional 2, so obviously that is 3 on the left side. Okay, and now we have 2w over 18. Okay, that brings us to the fifth and final step, is our 1 and 1 coefficient. Okay, now obviously we want a whole w here, and we do not have a whole w. We have 2/18 of 1. Okay, so we need to stop our w from multiplying times 2 over 18. Now, how do we do that? Okay, to stop it from multiplying, what we would want to do is divide. But as we've already said, it is very difficult to divide by fractions. So instead, we employ the leave, change, flip method. Leave your first term alone. That's the 2w over 18. Change from division to multiplication. And flip what was trying to divide. So instead of dividing by 2 over 18, we're going to multiply by 18 over 2. Leave, change, flip. We're going to multiply by the reciprocal. Okay, we introduced that into the problem, so we must do the same thing on the other side of the equal sign. Multiply by 18 over 2. Now on the right side, this is where some magic is going to happen. We now have an 18 in the numerator and an 18 in the denominator. Those will cancel. We have a 2 in the numerator and a 2 in the denominator, and those will cancel. That will leave you just the w. Okay. On the left side, we have in the numerator 18 times 3, that is 54, and in the denominator 2 times 1, that is 2. So we have a 54 over 2, which reduces nicely to 27. Now again, I'm not going to spend your time now checking it, but you would absolutely want to take this 27 and plug it back into the equation in place of w and make sure that that right side actually does equal 1. Then you box your answer and you're done. Okay, let's look at a different one. This time we are solving for y, and our equation is 2 times 4y plus 5 equals 17 minus y. Okay, we're going to start walking through our 5 steps. Parents, that's parentheses. Any multiplication that we have present needs to be done. And we do have some multiplication. We have 2 multiplying times the binomial 4y plus 5. By rule, that 2 needs to multiply by both of the terms of that binomial. So it needs to hit the 4y and it needs to hit the 5. 2 times 4y is going to be 8y, and 2 times 5 is going to be 10. So we have 8y plus 10 equals 17 minus 7. So that takes care of our parentheses. Step 2 is to combine like terms. Well, we do have a binomial on the left. It is 8y plus 10. You cannot add y's to constants, so those will not combine. And then we're going to see we have the same situation on the right side. We have constants and y's. They will not subtract. They are not like terms. Okay. Now, step 3, vary your variables all one direction. All right, now we got something to do here. We have variables on the left and variables on the right. We need to pick a side and send them one direction or the other. It does not matter which direction you send them. However, I tend to always try to keep my variables positive if I can. So that means I am going to bring the negative y from the right. I'm going to bring it over to the left by adding it. And I knew that that was going to happen just doing a little bit of mental math before I wrote this down, understanding that subtracting 8y's over to the right side would have caused negative variables. That's okay. You're just going to have to deal with that before the problem's over. So I try to keep them positive if I can. On the left side, 8y plus 1 more y is going to be 9. 9y's. The plus 10 is still there, and the equals 17 is still there. Now that takes care of our variables all going one direction. Now, since all of our variables went left, that means everything else needs to go right. So the plus 10 does not need to be hanging on to our variables like that. So how do you move plus 10 to the other side of the equal sign? We're going to subtract it. Okay, so we have introduced minus 10 into this equation, so we must do the same thing to both sides. So we're going to subtract 10 from both sides. Over there on the right, you had 17. You take away 10. There are 7 left. Okay, that takes care of everything else going the opposite direction. And now we are down to our 1 and 1, positive 1 coefficient, positive 1 variable. Now we have 9 y's in the problem. We do not want 9 of them. We want just 1. Okay, so we need to stop that 9 from multiplying against our variable. How do you stop multiplication? By using division. So we'll divide both sides by 9. That is going to give us a fraction over there on the right side. This is a rational fraction. Okay, it's going to come up with a decimal point that does repeat, but we try not to use those guys because we cannot round them off accurately. So it's just as good of a reason to leave this answer as a fraction. 7/9 is an exact value rather than rounding it off. In math, we would rather have exact numbers rather than approximate numbers. Okay, so we would take that 7/9 and we'd plug it back in both of the places of y and check it to make sure that 7/9 does actually work. And again, I'm not going to spend your time here doing that, but it would be a real good suggestion for you to do it, especially if you end up with an oddball answer like 7/9. Again, 4z plus 5z equals 27 over z. Now, true enough, you are going to start seeing more and more and more variables in your problems. Algebra 2 is going to be packed with them, where it is just giving you tons and tons and tons of variables. So you might as well get used to it. Your days of only having one nice, neat, easy to get to variable, those are pretty much just about over. Okay, so let's start walking through our 5 steps here and see what comes up first. Okay, first step, parentheses, any multiplication present in the problem. It doesn't appear to be, so it seems like we get away from step 1 this time. Okay, step 2 would be to combine like terms. Okay, on the left side, we do have more than one term, and looking at it, we have some z to the firsts, and then we have some more z to the firsts. We can combine like terms on the left-hand side. So we have 4 z's, and then we have 5 more z's. So how many z's is that? There are 9 of them. Okay, so that takes care of combining like terms. Okay, next we are on to our variables. Okay, so all of our variables go one direction. Now it's very clear that we have a problem here. We got variables on the left and variables on the right. So we're going to pick a direction to move the variables. But before making that decision, I see another problem, and that problem would be that you have z in your denominator. That is a big time no-no. We got to get that variable out of there. You will never be able to solve the problem as long as your variable exists in the denominator. So at our first convenience, which would be now, we need to get that out of there. Okay, so I am moving my variables to the left side because the right side is already kind of messed up. So I have z, and it's dividing the 27. I want to stop that z from dividing the 27. How do you stop something from dividing? By multiplying. So I'm going to multiply both sides of the problem by z. On the right side, that puts a z in the numerator and a z in the denominator, so they can cancel. Now on the left side, we've introduced another z. Well, there was already a z over there. Okay, so we've got 9, obviously, on the left. That's going to continue to exist. But now we have z times z. Okay, here's one of the things you've absolutely got to learn. A lot of people mistakenly think that z times z is 2z, and that is not true. If you multiply something times itself, you have squared it, not doubled it, squared it. So z times 9z is 9z squared, and we've taken care of the denominator over there on the right side, pardon me. Okay, so that takes care of the variables going all one direction. Now that brings us to everything else going the other direction. Well, there is nothing adding or subtracting to our z squared, so we don't have to worry about step 4. Step 5 would be your 1 and 1. Now here's really the first instance where we've seen this. We do not have a 1 coefficient for our variable. We also do not have a 1 exponent for our variable. So we need to deal with the 1 and 1 in both cases. Okay, now it is in that order. The coefficient is going to be dealt with first and then the variable. So I'm not worried about the z squared right now. Right now I'm worried about the fact that there are 9 of them. So I do not want 9 of them, I just want 1. So the next thing we're going to do is we're going to stop that 9 from multiplying times our z squared by dividing it. Okay, so if we divide both sides by 9, over on the right-hand side, we have 27 divided by 9. That is 3. Okay, so that takes care of the first half of the 1 and 1. We've got the 1 coefficient for our variable, but we do not want z squared. We want just z. So we need to get the square off of the z. So how do you stop something from squaring? The opposite of squaring is square root. If we will introduce a square root to both sides of the problem, it will stop z from being squared. But we also pick up an irrational number over there on the right side. Square root of 3 is a never-ending, never-repeating decimal point. That's why we call it irrational. And that is our value. There is no fraction to turn this into, and we do not want to round off because that actually changes the value. Square root of 3 is the precise answer. We will leave it exactly like that. Okay, one more. Let's take a look. Parentheses. Okay, do we have any multiplication to deal with in the problem? Absolutely we do. So there is something to look at for step 1. Okay, and basically what you need to remember here is when it comes to multiplication, numbers are going to seek out other numbers and variables are going to seek out other variables and so on. That's the rule for multiplication and division. So the 3 doesn't really mess with the v or anything. It is simply going to distribute in there. Okay, so we've got 12 v squareds, and that supposedly equals 48. Now I have a little error in my notes I just noticed, so if you can actually spot what went wrong, point that out to me. I'll give you some extra credit. But anyway, here we go. We got 12v squared equals 48. So that takes care of the parentheses. It's monomials on each side, so there's nothing to combine. Variables are all already one direction. Okay, and now everything else goes the other direction. Well, there's nothing being added or subtracted in there. Okay, so we get to go all the way to step 5, and once again, we're looking at the 1 and 1. We do not have a 1 coefficient or a 1 exponent, so we will deal with them in that order. Coefficient first, exponent last. This is like order of operations in reverse. Okay, so not worried about the v squared right now. What I'm worried about is the fact that there are 12 of them. So I want to stop that 12 from multiplying times v squared. Okay, so I'm going to divide both sides by 12. Okay, on the right side, 48 divided by 12 goes in nicely. That's 4. And now we are at the second half of the 1 and 1. We have 1 v squared, but we do not want it to be squared. We want it to be the first dimension v. Okay, so to stop it from being squared, we take the square root. And the square root of 4, obviously, is 2. And again, you would want to plug this number back in and check it and make sure that that left side of the problem up there actually does equal 48. And once you're sure, you put the box around it and you are done. Okay, so this is basically kind of the worst of the solving linear equations. Next year in Algebra 2, you'll get into non-linear equations and start looking at graphs that bend and stuff like that. And you will see quite a few of them in Algebra 2. But you need these basic problem-solving skills no matter what dimension your variables are in. These are the skills we've got to be able to do. Appreciate you finding time to get your notes taken care of, and I'll see you in class.